Let's talk about the incredible, invisible force that makes metal, well, metal. It's called the metallic bond, and it's this powerful connection deep inside every single piece of metal you've ever touched. We're going to dive in and see what's really holding our world together. I mean, have you ever really thought about it? How can you hammer a piece of copper into a super thin sheet when a rock would just shatter into a million pieces? And why does electricity just zip right through a wire so easily? Turns out it all comes down to one fundamental idea, a really unique kind of bond. So to get to the bottom of this, we've got to zoom in. No, I mean way, way in. The secret is buried deep inside the metal, right down at the atomic level, in a structure that's totally unlike anything else in nature. Okay, we're heading into a microscopic world now. I want you to picture this vast, shimmering ocean, but instead of water, it's made of pure energy. This is what we call the electron sea, and believe me, it is the key to everything. So check this out. A metal's internal structure really has two key parts. Over on the left, you see the lattice. Think of these as the metal atoms after they've given up an electron, so they become positive ions, and they're all locked into this rigid, repeating pattern. Then, on the right, you've got the electron sea. This is where all those lost electrons go. They become completely free to just roam throughout the entire structure, not tied to any single atom anymore. And that right there is the metallic bond. It's this powerful magnetic-like attraction between that fixed, positive lattice and the flowing negative sea of electrons. The amazing thing is, it's not a bond between just two atoms. It's a huge collective bond between all the atoms and all those free electrons at once. So how does this atomic glue actually work? Well, first, the electrons become delocalized. That's just a fancy way of saying they detach from their home atoms. This creates a really powerful electrostatic force. You know the rule, opposites attract, right? The now positive atoms are pulled super tight towards that negative cloud of electrons. And the result? An incredibly stable structure that holds together with just immense strength. Okay, so we've got this amazing model of an electron sea. It's a cool idea, but how does that tiny atomic structure explain why metals act the way they do in our world? Let's connect the dots from the theory to the things we can actually see and touch. And this is where that sea model just clicks into place. Because those electrons are free to move, applying a voltage is basically like turning on a faucet. They just flow, carrying an electrical charge with them. And the exact same thing happens with heat. Those mobile electrons transfer energy super fast through the metal, which is why a metal spoon in a hot cup of coffee gets hot almost instantly. You know, this fluid nature of the bond also explains why you can bend and shape metals so easily. When you hit a piece of metal with a hammer, the layers of atoms can literally slide past each other without breaking apart. That electron sea acts like a perfect lubricant, just adjusting to the new shape. We call that malleability, being able to hammer it into sheets. And it's also why metals are ductile, why you can pull them into long, thin wires. All right, we've covered conductivity and shape, but what about a metal's most famous features? Its incredible strength and that unique shine. And even more exciting, how do we take that natural strength and crank it up to 11? And this is the really crucial point. That attraction between the lattice and the electron sea is immensely powerful. This isn't some weak connection we're talking about. To pull those ions apart, to actually melt the metal, you have to pump in a massive amount of energy. And if you want a really dramatic example, just look at tungsten. To get solid tungsten to turn into a liquid, you need to heat it to over 3,400 degrees Celsius. That alone is just an incredible testament to the brute strength of the metallic bond holding its atoms together. So what about that iconic shine? Where does that come from? Well, you guessed it, it's the electron sea at work again. When light photons hit the surface of the metal, the free electrons in the sea absorb them and then immediately spit them back out. This rapid-fire reflection is what our eyes see as that classic metallic luster. So we know metals are naturally tough, but humans are never satisfied, right? What if we need them to be even stronger? For centuries, we've used this brilliant little trick. We intentionally mess up that perfect structure to create something way better. This shows you exactly how it works. In a pure metal, see how the orderly lattice lets those layers slide past each other nice and easy? That's what makes it ductile. But when we make an alloy by mixing in atoms of another element, those new atoms completely disrupt the neat layers. They act like little roadblocks, making it much, much harder for the layers to slide. The result is a harder, stronger material. And we use this trick everywhere. Pure iron is actually pretty soft.
But you add just a tiny bit of carbon and bam, you get carbon steel, an incredibly strong material that we use to build just about everything. Or you take softer metals like copper and tin, mix them together, and you get bronze, a much harder alloy that literally defined an entire age of human history.
So let's zoom back out for a second. From a simple electrical wire to the frame of a skyscraper, it all comes back to this one elegant concept, the sea of electrons. It really is our world's invisible glue. It's kind of amazing, isn't it? This one single, powerful model is the unified theory of metals. It perfectly explains why they conduct electricity and heat, why we can shape them without them breaking, and why they have such incredible strength. It all just makes sense when you see it through the lens of the electron sea. Okay, so let's do a quick recap. If you take anything away from this, remember these points. 1. Metallic bonds create a sea of free-floating electrons around a fixed grid of ions. 2. This mobile sea is what lets electricity flow and lets us shape metals. 3. The bond is super strong, which means high melting points and serious durability. And 4. By messing with that perfect grid, we create even stronger materials called alloys. Got it? Good. You know, from the Stone Age to the Iron Age to the silicon chips we use today, our ability to understand and control materials has defined human progress. The metallic bond is the invisible glue that has built our entire modern civilization. So the only real question left is, what are we going to build with it next?